This video will cover a walkthrough of the odd problems from 13 to 19 on page 644. In number 13, we have a sample of 1,178 births from December of 2006. Some of the mothers received an epidural and some did not, and we're tracking whether the baby is still breastfeeding 6 months after birth. This is going to be a chi-square test of independence, and there's a few ways we can figure that out. So first off, we're going to rule out chi-square goodness of fit, and that's done entirely based on the look of this table. So a goodness of fit test is when we have a single row of data, okay, or if it's arranged horizontally, a single column of data. When we have two dimensions, like here we have two rows and two columns, it's impossible to do this as a goodness of fit test. So we're down to a test of homogeneity or test of independence. Okay, homogeneity means we have two samples. We want to see, are they the same, quote unquote. Test of independence means we have two variables and we want to see, are the variables independent of one another? Are they affecting each other? So the reason this is a test of independence, or the way we can identify it, is first off, we have just one sample. Okay, if we don't have more than one sample, we can't do a test of homogeneity. So the fact that we only have this 1,178 sample of babies, of births, means that we can only do a test of independence. The other thing is that we have two variables here, and we want to see, does receiving the epidural influence whether or not a baby is breastfeeding at 6 months. Okay, so in other words, is there an association between these two? Or in other words, are these two variables independent of one another? When it comes to writing the hypotheses, we would write a baby's willingness to breastfeed is independent of whether the mother has an epidural during childbirth. Okay, we could also say there's no association between receiving an epidural and the likelihood of the baby breastfeeding at 6 months. Alternative is just the opposite of that. So we're either saying that they're not independent or there is an association between those two variables. Number 15 asks us a few questions about this table. So first off, it says, what are the degrees of freedom? Degrees of freedom for a two-dimensional table is rows minus 1 times columns minus 1. We have two rows. Okay, we have two columns. So 2 minus 1 times 2 minus 1 is 1 degree of freedom. What's the expected cell for epidural no breastfeeding? That's referring to epidural yes, no breastfeeding. So it would be this cell right here, that 190. Okay, so to figure out what that expected cell is, we take the row total, multiply it by the column total, divide by the grand total. Okay, so the row total, I think I have these backwards when I plug them in, that is 474. The column total is 396. We're going to multiply those two things together, and then we're going to divide by the grand total, 1178. That gives us what's expected in that cell if these two variables are independent, if the null hypothesis is actually true. Okay, we would expect to get 159.34 babies in that cell. Okay, instead we got 190, so we got a little higher than expected. Assumptions and conditions, we've checked these a few times now. 17, calculate the chi-square value for the epidural no breastfeeding cell. Again, that's that bottom left cell that we just dealt with on the last slide. So to find the chi-square value, observed minus expected, square that difference over expected. Observed is the 190 from the table. Expected is the 159.34 that we found on the last slide. Subtract them, square the difference, divide by the expected, and we get 5.90. That's the chi-square value for this specific cell. Each cell has its own chi-square value. When we add them all together, we get the chi-square value for the entire test. B tells us that chi-square value is 14.87. What's the p-value for that? Okay, just like normal CDF and t-CDF have their own functions in the calculator, chi-squared also has its own CDF. Okay, so we're going to go into distributions where you find normal set, CDF, and t-CDF. Lower and upper, we're always putting our chi-square value into lower. Upper, put in something like 99 or 999, and then degrees of freedom we know is 1. Okay, that gives us a p-value of 0.0019. Based on that, we're going to state our conclusion, reject the null hypothesis since the p-value is small. There's sufficient evidence to suggest that the baby's willingness to breastfeed is not independent of whether or not the mother has an epidural during childbirth. In number 19, it's giving us a new table, and in this table we have the residuals for each cell. You probably remember residuals back from Unit 2. A residual when we were dealing with scatter plots was how far each point was from the line of best fit. When we're dealing with chi-square tests, a residual tells us how far is this cell from the expected value. Positive means we have more, the count is higher than expected. Negative means the count was lower than expected. So we want to show the residual for epidural / no breastfeeding, again, that bottom left. All right, so we found 5.90 as the chi-square value for this bottom left cell. The residual is just the square root of that value. So square root of 5.90 gives us 2.43. Okay, the reason it's positive is because there's more data in this cell. The count is higher than we would expect. Okay, so a negative residual means that there's less data. The count for example, this spot right here is lower than we expected if these two variables were actually independent. So part B is saying, what can we conclude? There are more babies than expected in the no epidural still breastfeeding and in the yes epidural no longer breastfeeding groups. The other two groups have less babies than expected. This suggests that babies of mothers who don't receive an epidural are much more likely to be breastfeeding at 6 months of age. Now, when it comes to doing these problems in the calculator, we need to make a matrix. And this is a bit harder to do on the 89. So first step on the 89, hit the apps button. And instead of going to your stats list editor like we always do, you're going to look for data / matrix editor. You're going to select that one. Okay, create a new matrix. You have to name it something. You can name it whatever you want. But on that screen, you see an option to select the type. Make sure that you switch the type to matrix. That's the key step that a lot of students miss. And if you don't do it, you're not going to be able to run the test later on. On the 84, just hit the second button. You'll see 3 under that in blue letters. It says matrix there. Click on that one. Go over to the word edit. Okay, so at this point for both groups, make a 2x2 matrix for this problem, and then you can fill in your values. Once you have it filled in, go into where you would normally go to your hypothesis tests. On the 84, you're looking for a chi-square test. It's option C. And on the 89, you're looking for a chi-square two-way test. Okay, it's going to ask you for the observed matrix. That's probably matrix A on the 84. And on the 89, it's whatever you named it. Okay, expected, you can just leave as it is, and then hit either calculate or draw to get these values.